Hey class, Mr. Mohiddin here with a quick video on how to find a value to make a particular line tangent to a particular curve. So this is a pretty challenging problem conceptually, but once you realize what it's asking, the actual math is fairly straightforward. So let's make sure we understand exactly what a tangent line is compared to a function. So when you have some function, like this one here, the tangent line, we know by now, looks something like this, here in red. So I want you to think about something at this point. At this point, both the white curve and the red line have the same value, hence they cross, but they have the same slope, so they kind of cross only once, which is the idea of a tangent line, right? So their values have to equal and their slopes have to equal. So their values equaling is simply a matter of pre-calculus. You set the two functions equal to each other to find where they are literally equal. So my particular function here is y equals kx squared, which is some kind of parabola. It doesn't necessarily look like this. This was just a background conceptual concept here. So y equals kx squared is the value for our parabola, and we need that to equal the value of this line. So these two things need to equal each other. So in other words, we are equaling or equating their values so that they cross. But you could have a parabola and it could cross, but it could cross like that, and that's not a tangent line. It has no slope compared to the, or no tangent slope compared to the curve. So this will find you where they cross, and in order for them to be tangent, their slopes have to be the same. Well, a slope, conceptually, we think of in calculus as the derivative, so their derivatives also need to equal each other. So we need to also find, sort of as a simultaneous problem, their derivatives. Well, the derivative of the left-hand side, or the original function right here, y equals kx squared, is fairly straightforward. If y is equal to kx squared, then the derivative would be, well, k is a constant here, so it's just a constant multiple, so this will be 2x, so 2k times x. That's your derivative of the curve. The line that needs to be tangent to it is y equals negative 2x plus 3. Well, its derivative is just the slope of the line, derivative and slope being the same, so that would just be negative 2. So these two things also need to equal each other in order for them not just to cross, but to cross in a tangent way. So we also need to equate derivatives, which of course are, equates derivatives, which of course are the same as slopes. So we have two equations here. Let me write them on the next page so we can understand exactly what to do with them algebraically, but the reason we do this is because of a graphical understanding, that this function right here, or this equation right here, says the lines will cross, whereas this equation right here will say they'll cross in such a way that their slopes are the same. So if they're both true simultaneously, you have a tangent line. So we need to solve a relatively straightforward, simple system of equations. So let me get both equations on the same page here. Our first one was, get the y out of there, kx squared is equal to minus 2x plus 3, and the other equation we need to be true is 2kx is equal to negative 2, I believe it was. So we need these things both to be true. So this one looks fairly straightforward, so I'm going to solve that one for k, because ultimately I want to find k. So I'm going to solve this thing for k. So that would be k is equal to, if I divide both sides here by 2x, I get negative 2 over 2x, which further simplifies to negative 1 over x. So we now have sort of a way to interpret negative k in terms of x, which means we can now substitute this statement, k is equal to 1 over x, in place of k in the original function. We're basically using from algebra the substitution method, albeit one of our equations is nonlinear. So in place of k, I'm going to put negative 1 over x, and I'm going to multiply that by the rest of the function stays the same because that's the only k, so x squared is equal to negative 2x plus 3. So here, this side would simplify to negative x. Hopefully you can see that algebraically if you're not sure. Negative 1 over x times x squared would be, if you multiply these together, negative x squared over x, which is of course negative x times x over x, and these cancel, leaving it with negative x. Would equal negative 2x plus 3, so add 2x to both sides, and we would get x equals 3, which is nice. We now know where the where the point of tangency is, but to actually find k is equal to negative 1 over x, which we just found to be 3, so k is equal to negative 1/3. long story short, set the equations equal to each other to find where the equations will cross. Set the derivatives equal to each other to find where their slopes are the same, therefore it'll be tangent. Where they're both true, you have a tangent line. So solve this system of equations by solving one of them for k, plugging it into the other, and then finding x, and then going back and finding k. Alright, hope this helps.